Suhas Venkatesh.
Hello, everyone. I think everyone is having a nice time at the edge. So my name is Suhas. I'm working as Senior Solutions Architect at Akamai. Today, I'll just go back to the slides. So I wanted to welcome you all to the session with a quick quote from Tim Berners-Lee, who is the founder of World Wide Web. So the quote highlights the importance of data-driven decisions, which is our topic today. And please take a moment to go through the quote, and we'll get started with the session. Cool. So today's session is about real-time troubleshooting with Akamai logs, wherein I will be discussing more about what kind of log sources which are available from Akamai, how do we make a real-time decision based out of it. So in today's agenda, I would first cover the existing Akamai log services from existing Akamai log services. What are the different I'll try to differentiate between those three services, like when to use which service. Then I'll talk more about a Datastream, which is a newest product offering from Akamai. Then I will be showing a couple of demos on how to integrate Datastream with the open source tools like Graphana and how to make a data visualization out of it. Then we will have a Q&A session. I'm here also for a couple of days. You can catch me up if you want more information on the code or whatever demo we are trying to do in the session. So what's in it for me? Like we all know that the software development cycle has evolved from agile, so from the waterfall to agile to DevOps, right? And the continuous monitoring of the application and the infrastructure has become a critical component. But we all have a problem because we have too much of a data. With this data, like data varies from, we have data from real user monitoring tools, the synthetic testing tools, the system logs, the DB logs. There are a lot of data to look at. But again, the data cannot be ignored because we all know the importance of data-driven decisions. We need data, but the data needs to be captured in the right way. So today, in this session, I would cover those different sources which are required to collect the data. And more importantly, I would like to cover in depth on how Datastream works, how to integrate Datastream with different tools. By using a Datastream, we'll try to see how we can analyze the data in real time. And I'll try to integrate the Datastream with one of the open source tools like Graphana and try to make I'll try to explain how we can make a business decision out of it. So we'll get started with the first module, which is called Akamai Log Services. So here in the slide, I would like to cover three basic services. First one is the LDS, which is called Log Delivery Service. I think how many of you in the room have enabled Log Delivery Service from Akamai? OK, so a good amount of people are using LDS. So CloudMonitor? Anyone use CloudMonitor? OK, cool. So a couple of them. Yeah. So SIEM? OK. So what are the differences between these three services? The use case for LDS is to capture the raw logs between the client and the end user. It has a specific fields that will get captured. With the CloudMonitor, we will do the real-time delivery of data. Even the CloudMonitor has set of fields that get delivered. CloudMonitor also includes the security logs. With SIEM, we only try to capture security events. And SIEM will be used with the Akamai security products like Kona Site Defender, Bot Manager, and other products of Akamai security. Log delivery type, LDS supports push and pull. whereas CloudMonitor only supports push, and our SIEM also supports only the pull model of log delivery. Then the latency, when the data retention, when it comes to data retention, right? So what is data retention? Without maintaining an endpoint at your side, how much of data you can pull from Akamai? That is what the data retention is about. With LDS, you can pull the logs up to 7 days. Let's say you have configured the LDS, but LDS has failed for certain reasons. Maybe the FTP password has changed or anything. We can go up to 7 days back and regather the data with LDS. With CloudMonitor, there is no concept of data retention. Whatever the transaction which we capture between the client and edge, that has to be pushed to a specific endpoint. With SIEM, we can pull the data up to 12 hours. Then what is a latency? Latency is like how much time it takes to make the data available once the event has occurred. Like when I'm referring to an event wherein the request came to edge has responded to the client, and from there, how much time it takes to make the log data available. So with LDS, there's a highest latency. It is about 4 to 12 hours, whereas CloudMonitor and SIEM takes around less than a minute to get the data. Then rate limiting and control. Rate limiting and control is the ability to control the data access and gathering. With LDS, we don't have that limitation, whereas CloudMonitor and SIEM, with LDS, LDS and CloudMonitor, we can't control the data, whereas with SIEM, we can control the data. Let's say you have, for example, if you have an AWS endpoint, right? With the data rate limiting and control, we can set a usage limits on how much data needs to be posted to the AWS endpoint. Or let's say if you're pulling the data from Akamai, we can specify at what frequency the data needs to be pulled, and in each frequency, how much of data needs to be pulled. So this granularity is currently not supported in LDS and CloudMonitor, but we can achieve it in the SIEM. Now, data filtering part, again, like people who have used LDS, right? There is no concept of data filtering with LDS. Whatever the request came to edge, all those requests will be sent as part of logs. With CloudMonitor, we have a data filtering. Let's say you have an event, and we want to capture the logs only for that specific event. We can capture it using the CloudMonitor. And SIEM doesn't have a data filtering support today. So out-of-the-box connectors, we can see that LDS logs can be FTP'd into the customer endpoint, or it can be pushed to the nest storage. Whereas for CloudMonitor, we support BMC software and Sumo Logic. For SIEM, we support Splunk and SEF logs, which is a common event format for security logs. So quick time for a quiz, because I just gave an overview of different log services from Akamai. Which of the Akamai log service is used to capture only security events? C? Yes, cool. Then which of the Akamai log services supports real-time push-based log data? D? B? Yes. So today, the only log delivery service which provides near real-time data is CloudMonitor, but the only disadvantage is CloudMonitor only supports push-based service. We can't pull the data from Akamai, and there is no data retention within Akamai. So in the next module, I will try to introduce what is Datastream. I will provide how Datastream can be used, how Datastream differs from the existing modules of log delivery services. So in this slide, I would like to play a quick 90 seconds video, which provides an overview of how Datastream works.
Akamai Datastream, middle mile data turned into real-time insights. Today, whether streaming to millions or handling a big holiday rush, online users expect a perfect experience. And your DevOps teams work hard to deliver it. but they only have a peek at what's going on in the middle mile. Yet you know, being able to deploy new code or change configurations, all while seeing its impact on end users' experience in real time, is invaluable. Having the power and control in your delivery pipeline to proactively troubleshoot, fine-tune, or roll back in case things go wrong is priceless. But the middle mile has traditionally been a black box. So Akamai Datastream provides the visibility for you to do something about it. It's super simple. You choose what you want to see, giving your data context. Click for raw logs, aggregated metrics, errors, and events customized to your requirements. You also choose when you want to see it, with push and pull APIs, giving you insights from your data as you need it. Now with the what and when, you can understand the why, leveraging accurate real-time data, which leads to better business decisions and happier users. Don't be stuck behind the black box. Simplify. Get real-time insights on your middle mile with Akamai Datastream. Talk to your Akamai rep today.
So we will try to understand the key features of Datastream. The first key feature is real-time logs. We know CloudMonitor provides real-time logs, but Datastream has reduced the duration of latency to 10 seconds. So it's almost a near real-time with Datastream. Then Datastream supports both push and pull APIs. You can maintain an endpoint and we can push the data to the endpoint, or we can pull the data from the Akamai. We have a data retention up to 24 hours with Datastream. And out of the box, Datastream can be integrated with Amazon S3, Splunk, and Sumo Logic. So the other key feature of Datastream is its ability to aggregate the data. Currently, none of the existing log services provides the aggregation of that data. So when I say aggregation data, we have two types of logs. One is called raw logs, and the other one is the aggregated data. With the aggregated data, we get more meaningful and actionable data, specifying, like, for example, what is a CDN offload? Is it 80%? Is it 60%? At current time, what is an offload? So that is aggregated data which Datastream provides. Then it provides ability to filter the data. You can choose what data fields are required as part of the push or the pull, so that we only capture the necessary fields and not all the fields which are not required. Then the last one is the data on demand. With CloudMonitor, once you enable, the only way you can is to disable that. There is no way to switch it off and switch it on. With Datastream, you can turn it on and turn off whenever it's required. For example, you have a key event which is planned tomorrow, and you want to capture all the logs during that key event. You can turn on the Datastream only for specific duration. Once the event is over, you can turn off the Datastream. So how it works, the end user requests are mapped to the Akamai servers. That is the first transaction, numbered 1. Then the edge server, the request will go to the origin. If it is non-cacheable, or if it is cacheable, it will be served from the edge. Once the transaction is complete, the logs will be pushed to the data processors, which are Akamai data processors. Then third, the data processors, if you have enabled the aggregation, right, of the logs, then it aggregates all the data what has been collected. Then at the last, we either if you have configured to push the logs to a specific endpoint, then we are pushing it to either Amazon S3, Splunk, or Sumo Logic. But in case if we have enabled to pull the data, then we can write a connector to pull the data and integrate with any of the open source tools like Graphana and ELK. So in the next module, I would like to cover how to integrate the Datastream on Akamai. So it includes 4 steps. First is the Datastream creation. Second one is the configuration, wherein I'll choose whether I need to pick aggregated logs or raw logs. In case if it is aggregated logs, what are the data sets that I need to capture in the logs? In case what is the aggregation interval? We'll start from 1 minute to 1 hour. If I choose 1 minute, then whatever data is collected, aggregation will be run on that 1 minute collected data. Then hostname association. So we have a property manager. We have a data stream configuration. We need to tie it up. That is what we'll do in this step. And the last part is the data gathering, wherein once the data stream logs are available, how do we analyze the data stream logs? Like what should be done to gather the data from data stream? So we look at the first step, which is about data stream creation. In this, if anyone is using the old UI still, it is under configure data stream. In the new UI, on the left navigation, you will find the real-time logs. Under real-time logs, you will see a data stream. Then you just have to click on add stream. I just highlighted a bit. So after that, we move to the configuration part, wherein I'll choose what should be my data set, whether it is raw logs or aggregated metrics. I'll choose between this. Then next step would be to select the destination. If I am using a push versus pull, if I'm pushing the data to the endpoint, then I'll be choosing any of those three connectors like Splunk, S3, or Sumo Logic. If you're pulling the data from data stream, then you can leave this blank. You don't have to select any of these fields. Then if you are going for the raw logs, then these are the data sets that are available. These are not all the fields that I'm trying to cover. There are a good amount of fields under each category. But for an example, I've taken a couple of fields. So we have grouped into 6 categories currently. The first category is called message exchange data. This tries to capture the transaction between the Akamai and the client and Akamai. Like what was the request method? What was the request path? What was the client IP? So those kind of information are gathered under this. Second comes the network performance data. That is like once the Akamai edge just completed the entire transaction, how much time it took to complete the download. Let's say we are downloading an object from Akamai. So how much time it took to complete the download? What was whether the download was successful. Let's say we have a field called last byte. If it is 1, that means the download was successful. Let's say the client aborted the download during a transaction, then the last byte will be 0. Next comes the network data. In the network data, we try to capture the client-side network, how it was, whether the network, what is the network type, what is the throughput, what is the bandwidth with which the client connected to Akamai. Then the request header data. This includes all the request headers which was used during the request it was used as a request for Akamai. Then the geo-specific information. This includes all the fields. Again, this is all client-specific. I'm trying to capture which country the client is trying to connect from, what is the region, what is the latitude, what is the longitude. So all those information are captured under that category. And the last category is the response header data, which is more of once the response is constructed back to the client, I'll try to capture all the response headers. So with the aggregated data sets, we have again 5 data sets you can choose from. First one is the edge response time, how much time it took to respond to the client, and aggregation is based on an average. Next is the origin response time. How much, if let's say Akamai has to connect to the origin to pull the content, how much time it took to connect to the origin, and what was the average response time from the origin for that. Next comes the CDN offload. Here we'll try to analyze how much of the cache hit happened, and what is the offload rate. If the cache hit is higher or cache miss is higher, what is the current offload from Akamai? So all those are aggregated under this category. Then comes the traffic volumes. Here, it gives you the request per second. That this is the request per second to the edge, a number of requests coming to the edge per second. Then it also includes number of bytes per second. The last is the HTTP status code. It groups the responses into these 4 categories: 2xx, 3xx, 4xx, and 5xx. Here it will give you how many of the responses were in 2xx series. So it doesn't give you that, for example, how many of the responses were 200. That data is not available under this. It will only give at a higher level, wherein it says number of 2xx was 20, number of 4xx were 10, like that. Okay, so next step is to associate the data stream with the property manager. In this step, as I mentioned, this is a Datastream UI, okay, wherein I choose the property manager configuration, which should be tied to the Datastream configuration. Then next would be to add the Datastream behavior in the property manager. Okay, so as you all know by now, like when the request comes in, the property manager is the first that gets picked up. Okay, so in the property manager, I will add the Datastream behavior, which indicates that the data stream needs to be invoked. And in the data stream configuration, I will say that data stream needs to be associated with this config. Okay? And the last step is the data gathering part. So if you are pushing to a specific endpoint, then all the raw logs will be available at the endpoint. But in case if you are going for the pull model, here is the API for that. The API includes two key parameters. One is the stream ID. Whenever you create a data stream in Akamai, it will come up with a unique ID. That unique ID is the stream ID. Then if you are selected for raw logs, then the API endpoints differs between the raw logs and the aggregated logs. So you have to give raw-logs for the pulling of raw log data. Then this is how it will basically give you a JSON response. I'll try to highlight one of the specific response there. For example, if you take the geo response, right, it will give you the country, region, city, latitude, longitude, and there are other set of fields that gets captured. Then with the aggregated data, again, the endpoint varies. You give the same stream ID, but the endpoint says aggregate-logs. So the parameters for both the raw logs and the aggregated logs are what is the start time, what is the end time for which you need the data, and what should be your result set. This is the data control part which I was saying, which is achievable in Datastream, wherein you are saying how much of data needs to be pulled, how much of data needs to be gathered. Okay, so with this, again, we get a JSON response for this API endpoint also. But here, as I mentioned, it gives you on a very high level, wherein it says how much of responses were in 2xx, how much of the responses were in 4xx, and other things. Okay, so I'll quickly jump onto the demo. Before the demo, I would like to give you the overall workflow of how the demo works. So I will show you the two demos, one with the push workflow and one with the pull workflow. With the push workflow, what I'm trying to do is, whenever the client makes a request to Akamai Edge server, the request will be forwarded to the origin, or it will be served from cache. Then the data will be pushed to the Datastream aggregator. And Datastream aggregator, I am trying to collect the logs in the Sumo Logic endpoint. Okay? So this is the push workflow which I'll be demoing. Then with the pull workflow, which is a bit more complicated than push, here I'm trying to make a request again to the Akamai server. The request will be processed, and the logs will be pushed to the Datastream aggregator. Once the data is available at the aggregator stage, right? So what I'm doing is I'm writing a Node.js connector to try to pull the data from the Datastream aggregator. Then I will push it to the Prometheus gateway, which is again an open source time series database. And then the data gets, that Prometheus DB will pull the data from the Prometheus gateway and store it in its DB. Okay? Then the final is the Graphana, wherein I'll try to pull the data from the Prometheus DB. Okay? So this is the entire workflow. Again, if you see the way the workflow works, the data stream makes the logs available within 10 seconds. Okay? Now, and in each workflow, there can be a considerable amount of delay that can be introduced, but that is configurable. For example, if you want your Graphana to pull the data every 5 seconds, it is configurable within Graphana. Again, in Prometheus, you can also say like what is the frequency of data gathering, like whether it should be within 10 seconds or within 5 seconds from the Node.js program. Okay, so I'll jump onto the demo workflow. So I have my Node.js running. I'll try to expand this. So in this, it is trying to pull the aggregated metrics For the demo purposes, I have used aggregated metrics. So it is running every 10 seconds and trying to collect the data from the data stream. Then I have this Graphana dashboard, which shows the aggregated metrics. I'm not sure whether it is completely visible, but I'll go through this. So here, the first dashboard indicates the response by status code, right? For example, if you see here, there is a spike in 2xx, then there is a sudden spike in 4xx. So from this aggregated metrics, we get an actionable data. Like, during a time, why is my website having a spike in the 4xx series? Why is there's a spike in 200? Is there any cache miss? So in the next dashboard also, this dashboard provides you the response time from the edge. If the response time is going high, let's say you have a new site release, and you see that response time is going high, then this data should indicate that. And request by cacheability, here in this dashboard, it shows how much of requests were served from Akamai Edge, how much of requests were not served by Akamai Edge. So yellow line indicates that, right? And the last two dashboards are the number of bytes per second and number of hits per second. So again, you can see the spike, the variation in the number of requests coming to your website. So the typical use case for this dashboard is, let's say whenever you have a new site release, or like you can integrate the same dashboard if you're using the Graphana dashboard to monitor your infrastructure, right? You can integrate the Akamai Health also into that infrastructure dashboard so that you don't have to monitor two different dashboards. That is one. Second thing is, this gives you a high-level overview of how things are working with Akamai. For example, if I want to take a use case, let's say I'll take this use case. I see an increase in, like if I highlight on this, right, you can see that number of 5xx was 6, and number of 4xx were 124. So that indicates to me that, okay, something is going wrong with the site. So either I have to do a rollback, or either I have to dig deep on analyzing why things are failing with Akamai. So for that, what we can do is, at this point of stage, aggregated metrics provide us the right direction. Let's say it gave me an actionable data to go back and check why my 4xx are very high, right? So what I'll do after that is, I'll turn on the raw logs from Datastream, okay? So I'll just log in. Okay, so here the logs are getting pushed to the specific endpoint, and here I can try to check. I'll just change yeah. So from here, I'll try to analyze like the more data about what is 4xx. Like for example, if I go here, click on this specific field, and try to search for the response codes. Right, so here I see a status 403, okay? So one of the 4xx can be 403. So let's say you have enabled certain path to be denied for specific users, then that is also a cause for increase in 403, right? Or I can see some 404 also. I'll just try to gather that. So in this case, the response code was 404. Okay, so when I'm trying to connect for a specific URL, I'm getting a 404. Let's say something was misconfigured at your end, the URL structure was not proper or anything, and site got released. And if the actionable data says that the 4xx has got increased, then we can take a check at the raw logs. The raw logs should indicate, okay, so what exactly in 4xx was the issue? Like in this case, I see that the combination of 403 and 404 are the issues. Maybe in a different case, it can be because of misconfigured site structure or something. There can be a 404 was the actual cause of it, right? And even we can take a look at the server errors. Let's say if you want to analyze how the server, like after the new site release, what was the offload from Akamai? So that kind of actionable data is what you can get from Grafana, and then you can dig deep into the actual raw logs to get more information about how things are working with Akamai. Okay? So one key takeaway from this demo is two things. So you are seeing the data in real time. Okay, if you can see my Grafana getting updated in real time. So you don't, like, let's say your client complains that I'm not able to see a site which is on Akamai, right? Let's say your client complains with that specific requirement. Then you can get into this. You can see that in the Grafana that there are higher number of server errors, there are higher number of 4xx errors. Go to the raw logs, try to correct client IP, try to collect the URL for which the client was trying to use, try to collect the information about the ISPs, because all those fields are available within the raw logs. You can gather all the logs, and if you can specify, if you gather those such much, if you gather so much of an information and give it to the Akamai support team, they'll be able to get you the actual reason on why it was failing. Okay, so if you see that it will, with the current in the current scenario, if you I see a lot of customers reaching out to Akamai support team, and Akamai support team goes to and fro, try to collect more data, like where the client is trying to connect from, what is the URL, is it a global error, or is it only specific to one customer? So it takes time to gather those requirements and get to the actual issue. But with this, a lot of time is reduced. You can you can gather the data, you can see the data and try to analyze it, or you can get in touch with Akamai support team to get more information about it. So a quick summary. So in this session, we looked at three things. One is what are the existing log services from Akamai, the LDS, the CloudMonitor, and the SIEM part. Then we took a deeper look at the Datastream, how Datastream can overcome the current challenges what we have with the existing log services. Then at the last, we showed how Datastream can be integrated with the Sumo logic, and how Datastream can be integrated with the open source tools like Grafana, and how we can make a data-driven decision out of it. So quick call for an action. So I would say try enabling the Datastream. It is available for all the delivery products. Then adopt data-driven decision and make a fast and confident business decision. So for more resources, you can visit developer.akamai.com, wherein it is all the API documentations and Datastream documentations are available. You can even go to learn.akamai.com to know more about it. At the last, if you want to know more about how the Node.js was implemented, the connector which pulls the data from the Datastream, the code is made available at the GitHub. You can reach out to me if you have any questions on the code and how the code works and other thing. And that's it. Any questions? Yeah. I think Mike.
Oh, thank you. Will Datastream eventually retire CloudMonitor?
Sorry?
Will Datastream eventually retire CloudMonitor?
Yes. The plan is to like as we move further, right? Datastream will replace the CloudMonitor.
Okay. Is there a timeline when will be the end of life of a CloudMonitor?
I'm not sure about the timeline, but we are trying to hit that by the end of this year.
Oh. Will existing CloudMonitor customer will be able to automatically transition to the data?
Yeah, so that is being discussed. So we have thought about these challenges, but the plan from Akamai is use the Datastream for all the delivery products, use the SIEM for all the security events. So Datastream, two things that currently it is not made available is, one is to capture the security event logs. For security event logs, you still have to use SIEM. Okay. With CloudMonitor, you could have used the custom data sets, like custom fields could have been added. This is still not available with the Datastream. So Datastream is evolving. So once the Datastream is fully capable of replacing CloudMonitor, that is when we think about it.
Okay. Okay. Thank you.
Quickly, do we have access? I'm from Sprint. I don't know if we have access to the Grafana dashboard.
Sorry, I didn't get you.
Is it available right now, or we have to buy the
Which one?
dashboard, Grafana?
So Graphana is an open source.
Okay.
So you can download it. It's an open source data visualization tool. And what the dashboard which I showed, right?
Yeah.
You can import it as a JSON format and export it in your Grafana instance. So it is like just plug and play.
And I forgot to take a picture of the summary. Can you go back to the summary slide? So
Okay.
I can take a picture. Sorry.
Oh, sorry. Are TLS versions and ciphers available in the logs?
Sorry. Yeah.
Oh, sorry. Are TLS versions and ciphers available in the logs? The data stream?
So I didn't get your question.
Sorry. Are TLS versions and ciphers available in the logs?
TLS versions, it is not available, but it will be made available. Yeah, I think Mike will, because it will not be audible.
I've got a quick question. What kind of bandwidth should we expect if we wanted to get raw logs for our entire property set? Like, do you have customers currently using Datastream to stream the raw logs, raw request logs for large scale? And have they run into any issues?
So the one thing, the problem with providing all set of fields with the logs, right? It will be a lot of downstream processing at the customer end. So we are trying to reduce as much as possible and try to be very specific on what can help the customer. So with the data stream, it's already like if you go to developer.akamai.com and choose and try to visit the fields that are currently available, if you see that almost pretty much everything is covered for troubleshooting and analysis part. But in case if you think there are any other fields which are not there as part of it, you can just let us know.
That wasn't my question. I was wondering, like, what kind of, do you have customers who are currently using raw data stream logging, and what kind of, have they run into any issues with bandwidth? Because, for example, you'll be pulling gigabytes a minute, gigabytes a second. Like, what kind of scale are we talking about for the pipe?
Your question is more about, like, is there any issue with pulling the data?
Yeah, let's say we're doing like 1 million requests per hour or something, and
Okay.
I want request logs for every single one of those. What kind of bandwidth should we expect that we need?
I think I'm not able to get the question. Can I sync up later,
Yeah.
just after this? Yeah.
I have a question. Over here in the middle. Right here. Yes. You mentioned the custom logging not quite there yet with replacing CloudWatch. Same with LDS. LDS it gives you the opportunity to choose formats that do include the custom fields. So it sounded to me like Datastream is going to support the custom logging as well?
Yeah, so custom, with the LDS, we have something called custom field, wherein we try to put the data which is not available within whatever format we try to capture. Again, Datastream currently doesn't support that custom field, but that is again in the roadmap. Like many customers have requested for it. Until we support a custom field, I think it should not be a replaceable product for CloudMonitor and LDS. Yeah.
So is LDS going to be replaced as well eventually, or is that?
No, LDS will not be
Okay.
replaced. There's no plans for it.
Okay, thank you.
Hi. How long Akamai keeps the logs?
For Datastream,
Uh-huh.
it is for 24 hours.
Okay.
Any other questions? So Node.js connector is available in the GitHub. In case if anyone wants to know how the code is exactly done, you can sync up with me. Yeah.
Hey Suhas, this is
Yeah.
Suman here. Are you going to share the slides, or is it possible? Or
Slides, I think it should be shared. Yeah.
okay.
I can answer that. We are recording slides and audio and handing them over to your company, and then I'm not sure exactly when they're posted, but they are being recorded and they will be hosted. And we're out of time.
Thank you.